All right, let's take this a step further. Eventually, we're going to talk about how do we get equations of lines? How do we actually write these equations? So we're going to learn two different forms that equations of lines can be in. The first is called the slope-intercept form. And so the m in this formula stands for slope, and the b stands for the y-intercept. This formula is basically saying if you have an equation that's solved for y, that has y by itself, then the number in front of the x, in example 6a, that would be 1/2, the number in front of the x is always the slope, and the constant is always the y-intercept. So I can actually use this information to create a graph. I don't need to make a table of values. The y-intercept would be the place where the line crosses the y-axis. You can think of that as an initial value or a starting point. So the y-intercept is 3. That means this line starts on the y-axis at 3. If the slope is 1/2, slope is rise over run, that means I have to go up 1 and over 2 to get the next point. And I could keep doing this up 1 over 2 until I have enough points that I can connect the dots and draw a nice straight line. So we can also use this information to write equations of lines. If we know the slope, so I want to write the equation of a line with a slope of -3, and if I know the y-intercept. If my line passes through the point 0, 3, that tells me when x is 0, y is 3, that is the y-intercept. The y-intercept always has an x value of 0. So if m is -3, and then my y-intercept is +3, using my formula, my equation has to be y equals -3x plus 3. We can do something similar in example 8. This time they're giving us 2 points that the line goes through. One of those points happens to be the y-intercept. That's the one with the 0. When x equals 0, y equals -2, that tells me my y-intercept is -2. Again, the y-intercept always has an x value of 0. They don't tell us what the slope is, but we have a slope formula that says we can take our change in y over our change in x. My change in y is -7, my change in x is -1. That divides to give me a +7. So m is 7, that means y equals 7x, and b is -2, so y equals 7x minus 2. Now, one way you could check your answer in this case is you could take that point 1,5, and if you plug x equal 1 into the equation that we wrote, if you replace the x with 1, you get 7 minus 2, which is 5. You do get that y value of 5. It's kind of a nice way to check and make sure that your line actually works with the points that are given. So the slope-intercept form is a great formula. It lets you write the equation of a line if you know the slope and the y-intercept. Sometimes, though, we're not going to know the y-intercept. And I have another formula I want to show you that I like to use when I don't know the y-intercept, and that's my point-slope form. I have it written out in the notes. M is still the slope, and x1, y1 is now any point on the line. So let's see how that works with an example. If I want to find the equation of a line that has a slope of 2/3, so m is 2/3, and it passes through the point -3, 1. That point is my x1, y1. The x1 would be -3, and the y1 would be 1. The idea is then we can plug these numbers into our formula. Notice that I never plug anything in for the x and the y. I want my equation to have an x and a y because those are my variables. The whole point of the equation is to show how those variables are related. So I plug the numbers in, and then we could take this equation and solve it for y. Minus a negative becomes a plus, so I have an x plus 3 in the parentheses. I'm going to distribute the 2/3. 2/3 times x And then 2/3 times 3 over 1, the 3's actually cancel and you're just left with a 2 over 1 or a 2. Then to finish, we can add the 1. And so my final answer would be y equals 2/3 x plus 3. Let's do 2 more examples. Find the equation of a line that passes through the points 2, 5, and -1, 4. Anytime you want to write the equation of a line, you can use this point-slope formula. That means you have to know the slope, and you have to know a point on the line. I know 2 points on the line, but I don't know the slope, so I'm going to have to use my slope formula to compute it. I'm going to take the change in y, y2 minus y1, divided by the change in x, x2 minus x1. That gives me -1 over -3, or 1/3. And then I'm going to plug my numbers in. Y minus y1 equals the slope times x minus x1. We can do the exact same thing we did in the previous example. Get rid of the parentheses, so 1/3 times x. 1/3 times 2 would be 2/3. And to finish, I'll add the 5. -2/3 plus 5 over 1. I'm going to need a common denominator to do that. -2/3 plus 15/3 is 13/3. So my final answer would be y equals 1/3 x plus 13/3. Let's do one more example that's similar. Once again, they gave us 2 points, so I'm going to have to start by finding the slope. I'm going to take my change in y minus my change in x. That's -2 over 4, or -1/2. Then I plug everything into the formula. Y minus y1 equals the slope times x minus x1. X minus -1 is the same as x plus 1. We can distribute the -1/2. -1/2 times x, -1/2 times 1. To finish, I'm going to add 6 to both sides. So I have to figure out what is -1/2 plus 6 over 1. That is 11/2. So my final answer would be y equals -1/2 x plus 11/2. Now in this case, if you had wanted to work with decimals, and there was nothing in the instructions that indicated that you couldn't, it would be fine to do so. You could also write your answer as y equals -0.5 x plus 5.5. However, in the previous problem, we had fractions of 1/3, and I don't want you to change those into decimals, unless you're asked to, because you would have to do some rounding. 1/3 is actually 0.3 repeating, and when you have a repeating decimal, there really isn't a good way to plug that into an equation other than just leaving it as a fraction. So my advice would be leave things as fractions unless the directions ask you to change them into decimals. There's a lot of information in these 2 videos. Please let me know if you have any questions on this topic.